Hey guys, good evening, and welcome back again to your Unacademy in English channel. I hope all of you are doing great, having a good time. So my dear students, quickly let me know in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Let me know quickly in the chats with some fire emojis if all of you can hear me, if I'm perfectly audible and visible to every one of you. Let me know quickly in the chats, people. Everyone in the chats. Everyone in the chats. If all of you can hear me, if I'm perfectly audible, visible to everyone. All right, all right, all right. All right, people. Got it, got it. Just give me a second. Start. Okay. So, my dear students, today it's again going to be the most expected 25 concepts which I shall be discussing with all of you from the subject chemistry. And again, expect the questions directly or indirectly from this particular session. Okay? Perfect. So already we are done with top 50 concepts part 1, part 2, and technically this is part 3, wherein I shall be discussing 25 more concepts. Okay? Well, a lot of students are asking me about the duration of the session. Let me tell you, the duration of today's session is going to be between 1.5 to 2 hours. The duration of the today's session is going to be between 1.5 to 2 hours. Okay? All right? And at the same time, there will be a lot of people who would be waiting for the PDF of this particular session. The PDF of this particular session I shall be sharing on my Telegram channel, which is Wassim Bhat Chemistry Official. WASSIM BHAT Chemistry Official is the name of the Telegram channel on which I shall be sharing the handwritten PDF of the today's session as well. Okay? Perfect. And guys, for the upcoming days till Saturday, every day, I've scheduled one live session at 9 p.m. on this particular channel. So tomorrow again, we have got one more session, right, at 9 p.m. Day after tomorrow, I'll be taking one more session at 9 p.m. Similarly, till Saturday exactly. Okay? All right. So should we start? Should we start, people? I would need some fire emojis in the chats to begin the session. I would need some fire emojis in the chats to begin the session. And the ones who have not liked the session yet, let me tell you, liking the session is mandatory. Yeah? So do smash the like button right now. Okay? All right, people. Quickly, give me some green signal. Give me some fire emojis in the chats if all of you are ready. Quick, people, everyone. Everyone. Okay? Chalo. Let's get going. Let's get started with the today's session, people. Well, the first concept which I shall be discussing with you in the today's session, what is that going to be? That is going to be equivalent mass calculation. Equivalent mass calculation in case of acids. How do we exactly calculate equivalent mass of the acids, and what kind of questions can be framed from this particular topic? Try to understand very clearly what I'll be talking about. Okay? See, guys. First of all, there is a formula by means of which we calculate equivalent mass of any substance. There is a formula by means of which we calculate equivalent mass of any substance. And what is that formula? Formula is pretty simple. Equivalent mass of any substance is always equal to molar mass of the substance divided by n factor of the substance. Molar mass of the substance divided by n factor of the substance, right? So basically, if I need to calculate equivalent mass of an acid, equivalent mass of an acid will be equal to molar mass of an acid divided by n factor of an acid. Now the point is, how do we calculate n factor of the acids? Let's talk about that first. How do we calculate n factor of the acids? My dear students, it's again pretty much simple. Let me tell you, when we talk about the n factor of an acid, let me tell you, n factor of an acid is nothing but, that is the basis T of the acid. N factor of the acid is nothing but, that is the basis T of the acid. And how do we define the basis T of the acid? My dear students, basis T is defined as the number of H positives an acid donates, or the number of OH negatives an acid accepts. Now, what it means exactly? Let's try to talk about that. Yeah? So first of all, for example, I am taking an acid like HCl. Let's say we are taking one more acid, H2SO4. Let's say I'm taking one more acid, HNO3. Let's say I'm taking one more acid, H3PO4. Now you tell me, my dear students, this HCl, when you introduce HCl in water, how many H positives it's going to give? It's going to give one H positive. Similarly, H2SO4 is going to give two H positives. This will give one H positive. This will give three H positives. And the number of H positives an acid donates, the number of H positives an acid furnishes, the number of H positives that an acid gives, that defines the basis T of the acid. And whatever is the basis T of the acid, that's something I call as the n factor of the acid. So if I ask you, what is the n factor of HCl here? The answer is 1. What is the n factor of this acid? It's 2. What is the n factor of this one? It's 1. What is the n factor of this one? It is 3, right? And if you got the n factors, of these acids, you can calculate its equivalent mass as well. How exactly? I would say equivalent mass of HCl here would be equal to molar mass of HCl, which is 36.5 grams, divided by n factor of HCl, right? Similarly, equivalent mass of H2SO4 would be pretty much simple. That's going to be molar mass of H2SO4 divided by its n factor. Similarly, molar mass divided by n factor, I believe this particular point is clear to everyone. Yes? Right, people? Am I clear with this? Everyone in the chats? Everyone in the chats? Now, there are few things which you need to remember here. What are those few things? Let me talk about them. First of all, my dear students, let's say I'm taking an acid H3PO2. Let's say I'm taking an acid H3PO3. Let's say I'm taking an acid H3PO4. And similarly, I'm taking an acid H3PO5. Okay, these are the acids which I'm taking. Now, if I'm asking you, what do you think will be the n factor of this acid? A lot of students will say, since it has got 3 hydrogens, it will give 3 H positives. Its n factor should be 3. Its n factor should be 3. It should be 3. It should be 3. But that's not the case. Remember, my dear students, an acid donates only that hydrogen. Which will be attached to more electronegative element. An acid donates only that hydrogen in the form of H positive, which will be attached to more electronegative element like chlorine, oxygen, nitrogen. Okay, this is something which I would want every one of you to remember. For example, if you look at the structure of this H3PO2, my dear students, this H3PO2 looks like this. P double bond O, oxygen attached with hydrogen, right? Similarly, one more hydrogen. This is the structure of your H3PO2. Now look at all these hydrogens. out of all these three hydrogens, there is one hydrogen which is attached to more electronegative element like oxygen. So this acid is going to give only one H positive. That means this H positive. So its N factor will be simply 1, right? Similarly, when you look at the structure of this, okay, when you look at the structure of this, you will find there will be 2 hydrogens attached with oxygen. Here, you will find 3 hydrogens will be attached with oxygen. Here, you will find 3 hydrogens will be attached with oxygen. And those hydrogens which will be attached to more electronegative element like oxygen, they are going to leave as H positive. And the number of H positives an acid donates, that defines the basicity. And whatever will be the basicity of the acid, that's what you call as the N factor of the acid. So N factor of this is 1, this will be 2, this will be 3, this will be 3, right? And if you got the N factors, people, you can calculate their equivalent masses. Their molar masses divided by their N factors, right? Am I clear with this? Everyone in the chats, quickly. Now, there is one more thing which I would want to tell you here when it comes to acids. What is that? Understand, guys. There will be a question like this. Frequently asked questions. There will be a question like this. H2SO4 plus H2SO4 plus NaOH. NaOH. It gives NaHSO4 plus water. This will be the reaction that will be given to you. Number 1. Number 2, there will be one more reaction. H2SO4 plus 2 times NaOH. It gives Na2SO4, and with this, you'll be getting 2 times water. Okay. In both the reactions, they'll ask you to calculate the equivalent mass of H2SO4. In both the reactions, they would ask you to calculate the equivalent mass of H2SO4. Now, how do I calculate equivalent mass of H2SO4? How do I calculate equivalent mass of H2SO4? Again, pretty much simple. Equivalent mass is equal to molar mass divided by N factor, right? Now, my dear students, remember one thing. Remember one thing. I believe all of you would be knowing. Just a second, guys. Okay. I believe all of you would be knowing when one H positive combines with one OH negative. When one H positive combines with one OH negative, it gives one water molecule. Similarly, when two H positives combine with two OH negatives, they are going to give away 2 water molecules, right? This is something which I believe every one of you would be knowing. Now, my dear students, tell me one thing. Tell me one thing. Look at the number of water molecules here. I would say there is 1 water molecule. If there is 1 water molecule, what does it mean? It indicates this acid has given 1 H positive. This base has given 1 OH negative, and they have combined and formed 1 water molecule, right? Now tell me, how many H positives this acid is giving? This acid is giving 1 H positive, and the number of H positives an acid gives, that defines its basicity, and whatever is the basicity of the acid, that's something I'll be calling as the N factor of the acid. So N factor of HCl in the first reaction is 1, right? Now look at the second one. Over here, you have got 2 water molecules. If you have got 2 water molecules, what does it mean? It means this acid has given 2 H positives, this base has given 2 OH negatives, and they have combined and formed 2 water molecules. So I would say this acid over here has given 2 H positives, and the number of H positives an acid gives, that defines its basicity. And whatever is the basicity of the acid, that's something you call as its N factor. N factor of H2SO4 in the first reaction is 1, and here it's 2. If you got the N factors, you can calculate their equivalent masses. Molar mass of H2SO4 divided by N factor. Molar mass of H2SO4 divided by N factor. Let me know once in the chats if this particular concept is clear. Let me know once in the chats, people, if this particular concept is clear. Everyone in the chats. Everyone in the chats. Everyone in the chats, people. Quickly. All right. Perfect, people. Perfect, perfect, perfect. Let's move on. Let's move on to one more similar concept. That is basically, how do we calculate N factor of bases? How do we calculate N factor of bases? So technically, they'll ask us to calculate equivalent mass of bases. And as I told you, equivalent mass is nothing but equivalent masses. It is the molar mass of the substance divided by N factor of the substance, right? Now the point is, how do we calculate equivalent masses of the bases? Equivalent mass of base will be equal to molar mass of the base divided by n factor of the base. Now you must be thinking, how do we calculate n factor of the base? Let me tell you people, n factor of the base is nothing but, that is the acidity of the base. Acidity of the base. Now, how many ways are there by means of which I can define acidity? I can define acidity as the number of OH negatives a base donates. The number of OH negatives a base donates. Or I can say the number of H positives a base accepts. Number of H positives a base accepts. Okay. For example, talk about some common bases. Let's say you've got NaOH. Let's say you've got KOH. Let's say you've got MgOH whole twice. Let's say you've got AlOH whole thrice. Now tell me one thing. When you introduce all these bases in water, for example, how many OH negatives this base is going to give? It's going to give one OH negative. This is also going to give one OH negative. This will give two OH negatives. This will give three OH negatives. And the number of OH negatives a base furnishes, number of OH negatives a base gives, that's something we call as the acidity of the base. And whatever is the acidity of the base, that's what you call as the n factor of the base. So what is the n factor of NaOH here? N factor of NaOH here would be 1. Here it's going to be 1. Here it's going to be 2. Here it's going to be 3. And if you got the n factors of these bases, you can calculate their equivalent masses. How exactly? Molar mass of these bases divided by n factor of these bases. That's all. Right? That's all, people. That's all. Now, you tell me one thing. Let's say I have got a question like this. NH3, you are introducing in water. NH3, you are introducing in water. It's going to give NH4 positive, for example. This is the reaction which I'm giving you. I'm asking you people, what is the equivalent mass of NH3 in this reaction? What is the equivalent mass of NH3 in this particular reaction? So, equivalent mass is molar mass divided by n factor. So, technically, I have to calculate n factor of this NH3. Technically, I have to calculate n factor of this NH3. Now, tell me one thing. Do you see any OH here? No. Do you see hydrogens here? Yes. How many? 3. 3 hydrogens. When you are introducing it in water, it is getting converted into NH4 positive. How many hydrogens do you see here? You see 4 hydrogens. Over here, you see 3 hydrogens. Right here, you see 4 hydrogens. So basically, when NH3 is introduced in water, has it accepted one H positive or lost one H positive? I would say it has accepted one H positive. And the number of H positives a base accepts, that also defines its acidity. And whatever is the acidity of the base, that's what you call as its n factor. So I would say n factor of NH3 here would be 1. And if n factor of NH3 here is 1, it means you can easily calculate its equivalent mass. That means its molar mass divided by its n factor 1. Clear? Similarly, guys, there can be questions asked like this. Let's say the question is zinc hydroxide plus HCl. Zinc hydroxide plus HCl. For example, it gives ZnOHCl plus water. This is one of the reaction which I'm writing here. Similarly, there is one more reaction. Again, the same zinc hydroxide with 2 times HCl, right? And for example, it's giving ZnCl2 plus 2 times water. Now, for example, the question is asking, calculate the n factor of zinc hydroxide in both the reactions. Calculate the n factor. Calculate the n factor of zinc hydroxide in both the reactions. Will you be able to do this? Will you be able to do this, people? You should be in a position to solve this now. If you look carefully, one water molecule is produced here. One water molecule is formed here. That means this base has given one OH negative. This base has given one OH negative. And the number of OH negatives which are furnished by the base, that defines its n factor. So n factor of zinc hydroxide here in this reaction is 1. Right? Similarly, if you look at the second one, 2 water molecules we are getting. That means this base has given 2 OH negatives. 2 OH negatives, right? And the number of OH negatives furnished by the base defines its n factor. So n factor of zinc hydroxide here will be 2. In the first reaction, it's 1. In the second reaction, it's going to be 2. Am I clear with this? Everyone in the chats, people? Everyone in the chats? So remember, this was your second concept, which I would want you guys to remember from now on. There is one more important concept, my dear students. What is that? That is, how do we calculate equivalent mass in case of disproportionation reactions? How do we calculate equivalent mass in case of disproportionation reactions? First of all, you should know what these disproportionation reactions are. After that, I'll tell you how do we deal with this sort of a concept as well. Okay? See guys, for example, I'm taking a reaction like this. A2, it gives A positive plus A negative. Let's say this is the reaction. A2 gives A positive plus A negative. This is a general reaction. Now you tell me one thing. Do you see any charge on A here? No, I do not see it. Do you see any charge on A here? Yes, I can see +1. Do you see any charge on A here? It is -1. Correct? Now tell me one thing. Tell me one thing. 0 to +1. 0 to +1. Increase in the oxidation state. 0 to +1. Increase in the oxidation state. Right? Similarly, my dear students, 0 to -1. Decrease in the oxidation state. Increase in the oxidation state. Decrease in the oxidation state. Can I say oxidation state of same element? Oxidation state of same element is increasing as well as decreasing simultaneously. Yes, oxidation state of same element is increasing as well as decreasing simultaneously. Whenever you see oxidation state of same element increasing as well as decreasing simultaneously, we say that species undergoes disproportionation. We say that species undergoes disproportionation. And how do we calculate n factor of the species which undergoes disproportionation? My dear students, remember that n factor of the species which undergoes disproportionation is calculated by a simple formula. Formula is n1 multiplied by n2 divided by n1 plus n2. Now you must be thinking what this n1 is all about, what this n2 is all about. Let's try to understand. See guys, 0 to +1, 0 to +1, 0 to +1. What is the change in the oxidation state? See, 0 to +1, what is the change in oxidation state here? It's going to be final oxidation state minus initial. Final minus initial. The value is 1. 1 is the change for one atom. I have 2. 1 is the change for one atom. I have 2 atoms. So 1 into 2 is equal to 2. So N1 value is 2. N1 value is 2. Similarly, 0 to -1. 0 to -1. Decrease in the oxidation state. Decrease in the oxidation state is what you call as reduction. Decrease in the oxidation state is what you call as reduction, right? 0 to -1. Tell me what is the change in oxidation state here? 0 to -1. What is the change? Final minus initial. The value is again 1. 1 is the change for one atom. I have 2. 1 is the change for one atom. I have 2. So N2 value is also 2. So I got N1, I got N2. So it's 2 multiplied by 2 divided by 2 plus 2. The value comes out to be 1. So 1 is going to be n factor of A2 in this particular reaction, right? For example, I'm giving a question here. You are going to tell me its answer. I'm giving you the reaction Br2 gives Br negative plus BrO3 negative. Now I'm asking you to calculate the equivalent mass of Br2. I'm asking you to calculate equivalent mass of Br2. I believe you can easily do it. Molar mass of Br2 divided by n factor of Br2. Molar mass of Br2 divided by n factor of Br2. So technically, I have to calculate n factor of Br2 because its molar mass would be given in the question. Now, people, just understand one simple phenomenon. What is the charge on bromine here? 0. Charge on bromine here, -1. We can calculate charge on this bromine as well. I mean the oxidation state of bromine. We can do that. Let the oxidation state of bromine is X. The most common oxidation state of oxygen is -2. There are 3 oxygen atoms. Net charge is -1. The value of X comes out to be +5. So this bromine is in +5 oxidation, right? Now you tell me one thing. 0 to -1. 0 to -1. Decrease in the oxidation state, right? 0 to -1. Decrease in the oxidation state. Similarly, 0 to +5. Increase in the oxidation state. So can I say oxidation state of same element is increasing as well as decreasing simultaneously? Yes, oxidation state of same element is increasing as well as decreasing simultaneously. So I would say this particular species undergoes disproportionation. And how do I calculate its n factor? It's N1, N2 divided by N1 plus N2. Now, what are we supposed to do? We are supposed to get the value of N1 and we are supposed to get the value of N2, right? Let's get that. See guys, 0 to -1. 0 to -1. What is the change in the oxidation state? Final minus initial. The value is 1. 1 is the change in the oxidation state. For one atom of bromine, I have 2. So 1 into 2 is 2. N1 value is 2 here. Similarly, 0 to +5. 0 to +5. Tell me the change in the oxidation state. 0 to +5. Change in the oxidation state. Final minus initial. The value is 5. 5 is the change for one atom. I have 2. So 5 2s are 10. So N2 value is 10. Right? So I would say it's 10 multiplied by 2 divided by 10 plus 2. The value comes out to be 5 by 3. So 5 by 3 is the n factor of Br2. If 5 by 3 is the n factor of Br2, you can easily calculate its equivalent mass, molar mass of Br2 divided by n factor. Done and dusted, right? Quickly in the chats, people. Quickly in the chats. By the way, tomorrow at 9 p.m., there is one amazing session which I'll be taking. I'll be discussing just 30 PYQs with you tomorrow. Just 30 PYQs, right? To watch that session, that's going to be very, very, very helpful. Tomorrow at 9 p.m., I'll come live again. Okay? Perfect. Now, guys, let's move on to one more concept. Let's move on to one more concept. Just give me a second. Just give me a second. A relation between KP and KC. Again, if you see your May 3rd examination, there was a question asked from this topic as well. A relation between KP and KC. See, guys. For example, I have got a gaseous phase reaction like this. N1A gives N2B. Imagine this is your gaseous phase reaction. Imagine this is your gaseous phase reaction. Okay? This is your gaseous phase reaction. Now, first of all, how many moles do you see on reactant side? N1. How many moles do you see on product side? N2. Okay? The first thing, my dear students, how do we calculate delta Ng for the reaction? Delta Ng for the reaction is calculated as number of moles of gaseous products minus number of moles of gaseous reactants. Number of moles of gaseous products minus number of moles of gaseous reactants. How many moles of gaseous products do you see? N2 minus. How many moles of gaseous reactant do you see? N1. So first of all, delta Ng for the reaction is N2 minus N1. Perfect. Now, what is the relation between Kp and Kc for a gaseous phase reaction? Remember, Kp is equal to Kc RT raised power delta Ng for a gaseous phase reaction. This is the result, my dear students, which I would want every one of you to remember. Well, after remembering this result, what all other things you have to know? Pretty much simple. What is that? My dear students, remember, if delta Ng for the reaction is 0, if delta Ng for the reaction is 0, anything raised power 0 is 1. So I would say Kp and Kc would be equal. Kp and Kc would be equal. Similarly, if delta Ng for the reaction is non-zero, I would say Kp and Kc won't be equal. There are questions asked from this particular thing as well. Frequently asked question. In which of the following reactions Kp, Kc are equal? In which of the following reactions Kp and Kc are not equal? Those are the questions which are asked. So let's have a look exactly how these sort of questions are tackled. See, for example, just to make you familiar with the formula, let's say these are some simple questions. Write Kp expression in terms of Kc. Write Kp expression in terms of Kc. My dear students, if you look at the first reaction, calculate its delta Ng. Delta Ng is equal to number of moles of gaseous products, which is 2, minus number of moles of gaseous reactants, which is 1 plus 1, 2. So 2 minus 2 is 0. And when delta Ng for the reaction is 0, few minutes back I told you, your Kp and Kc would be equal. Done and dusted. For example, second reaction. Tell me what would be the delta Ng for this reaction. It is equal to number of moles of gaseous products, which is 1 plus 1, 2, minus number of moles of gaseous reactant, that's 1. The value is 1. Perfect. So you got delta Ng value. If you got delta Ng value, Kp would be equal to Kc RT raised power delta Ng, that is 1. Perfect. Simple and basic. Similarly, my dear students, if I talk about third reaction, what is the value of delta Ng for third reaction? Number of moles of gaseous products minus number of moles of gaseous reactants. 3 plus 1, 4. The value is minus 2. If delta Ng is minus 2, remember Kp would be equal to Kc RT raised power delta Ng, which is minus 2. Pretty much simple. Yes? Right, people? Similarly, guys, for the last reaction, can you calculate delta Ng for the last reaction? Number of moles of gaseous product. This is not the gaseous product. This is the gaseous product. And its moles are 1. Minus number of moles of gaseous reactant. There is no gaseous reactant. So delta Ng is 1. So you would say Kp is equal to Kc RT raised power 1. Okay. There are questions asked. Calculate the ratio of Kp by Kc. I would say the ratio of Kp and Kc here is RT. The ratio of Kp and Kc here is RT. The ratio of Kp and Kc here is RT raised power minus 2. These sort of questions are asked as well. Yeah? Right, people? Okay. Can you check this particular question based on the same concept? Can you check this particular question based on the same concept? Everyone? In which of the following Kp and Kc are not equal? In which of the following Kp and Kc are not equal? Tell me that. I told you a few minutes back, Kp and Kc won't be equal for the reaction. Kp and Kc won't be equal for the reaction whose delta Ng is non-zero. Right? Whose delta Ng is non-zero. I can see everyone is giving the correct answer. Amazing. Amazing, guys. Amazing. So this is the reaction in which delta Ng is non-zero. So I would say this would be the reaction wherein Kp and Kc won't be equal. Correct? Similarly, my dear students, there is one more concept which is asked here. That is about the characteristics of equilibrium constant. The question is frequently asked from this as well. The question is frequently asked from this as well. So what is this particular topic all about? You just have to remember a few things. Just 3 things you have to remember, guys. Just 3 things you have to remember here. And what are these 3 things? Just try to understand. My dear students, if you have got the reaction like this, A gives B. Let's say its equilibrium constant is K. You have got the reaction, A gives B. Its equilibrium constant is K. Right? My dear students, if you reverse the reaction, on reversing the reaction, equilibrium constant is inversed. That means, if the equilibrium constant of this reaction was K, here is going to be 1 by K. Point number 1. Point number 1. Point number 2. You've got the reaction A gives B. Let its equilibrium constant is K. Let its equilibrium constant is K. If you multiply a reaction by some number, that number goes to the power of equilibrium constant. That number goes to the power of equilibrium constant. What does that mean? For example, I'm multiplying this reaction by some number 2. It becomes 2A gives 2 times B. I multiplied this reaction by number 2. So that 2 goes to the power of equilibrium constant. So I would say now the equilibrium constant of this reaction will be K square, K raised power 2. If I multiply this reaction by number 3, equilibrium constant becomes K raised power 3. Right? Pretty simple. Now, remember one more thing. For example, you have got the reaction like this. A gives B, whose equilibrium constant is K1. One more reaction. C gives D, whose equilibrium constant is K2. Now you're adding these 2 reactions. When you add these 2 reactions, this is something which you'll be getting. This is the net reaction which you get. And my dear students, when you add the reactions, equilibrium constants are multiplied. When you add the reactions, equilibrium constants are multiplied. So I would say equilibrium constant of this reaction, let that be K3. So K3 will be K1 multiplied by K2. These are just the 3 things which I would want you guys to remember, and you can easily solve the questions. The first thing, when you reverse the reaction, equilibrium constant is inversed. When you multiply a reaction by some number, that number goes to the power of equilibrium constant. Right? Third thing, on adding the reactions, equilibrium constants are multiplied. That's all. Right? That's all. Perfect? Perfect, people? Am I clear with this? Am I clear with this? Am I clear with this, people? Everyone in the chats? All right. So, for example, let's try to solve a few questions. Some simple questions. Let's say you got the question like this. And these are the questions which are frequently asked. People. Let's try to check how these sort of questions are asked in the examination. Understand properly what I'll be saying. You are given 3 reactions and their equilibrium constants are given. K1, K2 and K3. I'm given 3 reactions I'm giving you 3 reactions and their equilibrium constants are given. Now, as per the question, I need to calculate equilibrium constant of this particular reaction. I need to calculate equilibrium constant of this particular reaction. Correct? Try to understand, people, what I'll be doing. Remember, the reaction whose equilibrium constant is to be calculated. The reaction whose equilibrium constant is to be calculated. You are supposed to make that reaction. You are supposed to make that reaction from those reactions whose equilibrium constant will be given to us. Again, the reaction whose equilibrium constant is to be calculated. You are supposed to make that reaction from those reactions whose equilibrium constant are given to us. Right? So technically, I'm supposed to make this reaction from these 3. Okay. Now, how do I do it? Just use common sense. Just use common sense, people. Understand properly. First of all, the reaction which I have to make. In this reaction, I can see NH3 on left side. Do you see NH3 anywhere here in these reactions? Yes, I can see NH3 here, right? But on the right side. But the point is, I need NH3 on left side. So I'll be reversing this reaction. When I reverse this first reaction, it becomes 2 times NH3. It gives N2 plus 3 times H2. And on reversing the reaction, equilibrium constant is inversed. So if equilibrium constant of this reaction is K1, now it's going to be 1 upon K1. Perfect? Simple. Now, my dear students, one more thing. I can see 2 times NO here. Right? In these reactions, do you see NO somewhere? Yes, I can see it here. Right? Perfect. And this NO is already on right side. Where do I need it? I need it on right side only. And it's already on right side. So do not do any change with this reaction. Keep it as such. N2 plus O2. It gives what? It gives 2 times NO. Its equilibrium constant as such K2. Perfect. Now, people, I need 3 times water on right side. But here we have got only water on right side. But I need 3 times water. So I'll multiply this reaction by number 3. So it becomes 3 times H2 plus 3 divided by 2 times O2. It becomes 3 times water. Right? So when you multiply the reaction by number 3, that 3 goes to the power of equilibrium constant. So it is K3 raised power 3. It's K3 raised power 3. Now do one thing. Just add these 3 reactions. When you add these 3 reactions, this term cancelled. This term cancelled. Right? So it becomes 2 times NH3 plus 3 by 2 O2 plus O2 makes it 5 by 2 times O2. It gives me what? It gives me 2 times NO plus 3 times water. Perfect. This is the reaction which I was supposed to make. How did I make this reaction? I made this reaction when I added these 3. And when you add the reactions, equilibrium constants are multiplied. So I would say equilibrium constant of this reaction would be, it's going to be 1 upon K1 multiplied by K2 multiplied by K3 raised power 3. Perfect. Is this particular concept clear? Tell me once the chat's quick. Is this particular concept clear, guys? Tell me once the chat's quick. Quickly in the chats. Everyone. Everyone, be quick, guys. Be quick, everyone. Amazing. Now let's talk about one more concept, that's your Lee chat layer principle. I'm not going into the depth of Lee chat layer, what it's all about, etc. I'm not going to talk about that. I'll just talk about those things by means of which you'll be able to solve the question. Just those things. And this is a very important one. It's a very important concept, right? Questions are frequently asked from this. Understand? My dear students, remember one thing. Whenever you have the reaction at equilibrium, okay? Whenever you have the reaction at equilibrium, whatever we do to the reaction at equilibrium, whatever we do to the reaction which is at equilibrium, equilibrium does opposite of that. Whenever you see a reaction which is at equilibrium, whatever we do to that reaction, equilibrium is going to do opposite of that. Okay? Equilibrium is going to do opposite of that. Now, what does that mean? Just try to understand few things and you're done, you're sorted. See, guys. First of all, remember, for example, you have got the reaction. The reaction is something like this. R gives P. The first point, guys. If you increase the concentration of reactant, equilibrium will try to decrease it. If you increase the concentration of reactant, equilibrium will try to decrease it. How will equilibrium decrease the concentration of reactant? It will favor equilibrium shifts in the forward direction. So equilibrium shifts forward. Simple. If I increase the concentration of reactant, equilibrium has to decrease it. How? Forward shift. Simple. Similarly, if you decrease the concentration of reactant, equilibrium will try to increase it. How? Backward shift. Backward shift, right? If you increase the concentration of product, equilibrium will try to decrease it. How? Backward shift. Backward shift. And if you decrease the concentration of product, equilibrium will try to increase it. How? Forward shift. Perfect. Remember, there is a point here. On adding or removing a solid at equilibrium, there will be no shift, neither forward nor backward. What does that mean? I'll just tell you, just remember it. My dear students, for example, you have got the reaction like this. Calcium carbonate solid in equilibrium with calcium oxide solid plus carbon dioxide gas. Do you see in this reaction, this in solid state, right? If you increase or decrease the concentration of calcium carbonate, if you increase or decrease the concentration of the amount of calcium oxide, right? There'll be no shift. Because this in solid state, If you increase or decrease the amount of that reactant or product which is in solid form, there'll be no shift at all. Remember it directly. So on increasing the amount of calcium carbonate, nothing will happen. On decreasing the amount of calcium oxide, nothing is going to happen. Okay. This is one important point which I would want every one of you to remember. Now, my dear students, point number two. This was point number one. Point number two. Remember, when you increase the pressure, equilibrium shifts in the direction in which gaseous moles will be decreasing. On increasing the pressure, equilibrium will shift in the direction in which the gaseous moles decreases. For example, what does it mean? See, guys, let's say you got the reaction like this. A gas, it gives B gas plus C gas. Imagine it's a balanced chemical equation. Now, I'm asking you, how many gaseous moles do you see here? 1. How many gaseous moles do you see here? 1 plus 1, 2, right? So in the forward direction, I would say gaseous moles are increasing. In the backward direction, I would say gaseous moles are decreasing. Correct? Now, my dear students, if you increase the pressure, on increasing the pressure, equilibrium shifts in the direction in which gaseous moles decrease. In which direction gaseous moles decrease here? Backward. So there'll be backward shift. Correct? For example, you've got the reaction like this. 2 times A gas, it gives B. Let's say this is the reaction. How many gaseous moles do you see here? 2. How many gaseous moles do you see here? 1. So in the forward direction, gaseous moles are decreasing. In the backward direction, gaseous moles are increasing. Now, if you increase the pressure, equilibrium will shift in the direction in which gaseous moles are decreasing, and gaseous moles are decreasing here in the forward shift, right? So there'll be forward shift. Perfect, there'll be forward shift. Remember, my dear students, that particular reaction whose delta Ng would be 0. Remember, on changing the pressure, there'll be no shift. That particular reaction whose delta Ng is 0. If you increase or decrease the pressure, there'll be no shift at all. Okay, this again one more important concept which I would want you guys to remember. Similarly, third concept here. In case of endothermic reactions, do remember equilibrium constant is directly proportional to temperature. And on increasing the temperature, there'll be forward shift. Right? And similarly, in case of exothermic reactions, my dear students, do remember equilibrium constant is inversely proportional to temperature. And remember, on increasing the temperature, there'll be backward shift. there'll be backward shift. One is for endothermic reaction, one is for exothermic reaction. Okay? Right, people? Am I clear with this? Am I clear with this? Everyone in the chats quickly. Everyone in the chats quickly. Now, people, there is one more important thing. Remember it directly as well. On adding inert gas, add constant pressure. On adding inert gas, add constant pressure. Equilibrium shifts in the direction in which gaseous moles will be increasing. On adding inert gas at constant pressure, equilibrium will shift in the direction in which the gaseous moles will increase. Remember this as well. And at the same time, when you add inert gas at constant volume, there'll be no shift. Right? And similarly, when you add catalyst, again, catalyst has got nothing to do with the equilibrium constant. Okay? Perfect, guys? Perfect. Sir, screenshot lena hai, le lo jaldi se screenshot. Anyways, I'm going to share this PDF in the Telegram. Now, my dear students, tell me the answer of all these questions. Quickly in the chats. Quickly in the chats. Quickly in the chats, people. You should be able to solve this question easily. First of all, if you look at the reaction, in this reaction, what is happening? It is absorbed. It is absorbed during the reaction. If heat is absorbed during the reaction, so the nature of the reaction is endothermic. So this reaction you will consider as endothermic. Now, on adding H2, if you add H2, if you increase the amount of H2, equilibrium will try to decrease it. How? Forward shift. When you increase the amount of NH3, equilibrium will try to decrease it. How? Backward shift. Right? Since it is an endothermic reaction, on increase the temperature, forward shift. Inert gas is added at constant volume, no shift. Inert gas is added at constant pressure. When inert gas is added at constant pressure, equilibrium shifts in the direction in which the gaseous moles increases. Right? In which direction gaseous moles are increasing? In the backward direction. So there'll be backward shift. Pretty much simple. Yes? Pretty much simple, people. Pretty much simple. Tell me the answer of this particular question, quickly. Tell me the answer of this particular question. Quickly, people. Quickly in the chats. What do you think about this one? Everyone in the chats. I want you guys to write the answers in the chats. I'm looking at your chats only. Everyone, guys. Everyone. Done and dusted? Well, I can see a lot of students are saying B. Here is where you make the mistake. My dear students, let me tell you, this NaNO3, its phase is solid. NaNO3 is solid in nature. Number one. So you are decomposing NaNO3. And it's getting converted into NaNO2, which is also solid. With that, you get O2 gas as well. So first of all, you are decomposing NaNO3. And decomposition happens in presence of heat. So this particular reaction is endothermic. Right? Now, people, addition of NaNO2. NaNO2 is in solid form, there will be no shift. So this cannot be the answer. Addition of NaNO3. NaNO3 is in solid form, there will be no shift. This cannot be the answer. Since the reaction is endothermic, and in case of endothermic reactions, when you increase the temperature, forward reaction happens. When you decrease the temperature, backward reaction happens. So on decreasing the temperature, forward reaction happens. No, backward reaction happens. So this cannot be the answer. Only one left is option D. Am I done with this? Am I done with this, people? Quickly in the chats. I believe you should be in the position to solve each and every question from here. Okay. Well. This is one more concept. And this is directly, the examples will be asked. Examples of extensive properties, examples of intensive properties. Remember them directly. Okay. Remember them directly. Examples of extensive and intensive properties, people. Yeah. Remember them directly. I believe every single thing is clear till here. Yeah. Now I'm moving on to one more thing. First law of thermodynamics. First law of thermodynamics, right? First law of thermodynamics. My dear students, you won't be asked the question, the theoretical question from this. You won't be asked with a theoretical question. There'll be a numerical given to you. There'll be a numerical given to you. And my dear students, wow, someone is asking in the chats, what are you doing in the chat? What's happening? Someone is asking someone, what is pain? What is the meaning of pain? Right? Just wait for 21st May, you'll understand what is pain. All right, let's move on, people. Let's move on. Let's move on, yeah? The duration. I'll take half an hour more. Okay. So my dear students, first of all, when you talk about your first law of thermodynamics, one equation which you need to remember, that is delta U is equal to Q plus W. Delta U is equal to Q plus W. Delta U is equal to Q plus W. And you have to be careful with the sign conventions. And what are the sign conventions, my dear students? Remember, whenever system absorbs heat, whenever system absorbs heat, remember, Q value is taken as positive. Q value is taken as positive. And whenever system releases heat, system means the gas. Whenever system releases heat, remember, Q value is taken as negative. Q value is taken as negative. Okay? Now, my dear students, one more thing. Whenever the gas undergoes expansion, expansion means volume increasing. Whenever the volume of the gas increases, we say the gas undergoes expansion. And whenever gas undergoes expansion, W value is taken to be negative. And whenever the gas undergoes compression, W value is taken as positive, right? In chemistry. Perfect. At the same time, there are a few more things which you need to take into consideration. If I ask you, what are the units of energy? What are the units of energy? This is important here because they might mess up with the units as well. So people, remember, when I talk about the SI unit of energy, SI unit of energy is joule, right? There are some other units of energy as well, which we use in this chapter. What is that? There's a term called as ATM liter. There's one more unit of energy, which I'll be using. There's a term called as bar liter. One more unit of energy. And remember, my dear students, 1 ATM liter is equal to 101.3 joules and 1 bar liter will be equal to 100 joules. Few things which you have to remember and you're sorted. And at the same time, there's an expression to calculate work here. Remember directly, in case of irreversible processes, it is minus P external delta V. Now let's see what kind of question can be framed. I'm writing a question here and you are going to answer it. During the compression of a spring, this is the asked question. During compression of a spring, during compression of a spring, 10 kilojoules of work was done and 2 kilojoules escaped to the surroundings. Escape to the surroundings as heat. As heat. Calculate delta U in kilojoules. Can you tell me the answer of this question? Every one of you in the chats. I just want to know. I just want to know. I'll give you 1 minute. After that, I'll start solving this question. Quick, people. Everyone in the chats. Everyone in the chats. These are the frequently asked questions from your first law of thermodynamics. Everyone, people. Everyone, people, quickly in the chats. I want everyone to let me know in the chats quickly, quickly, quickly. Yeah? Amazing. So, my dear students, you are compressing the spring. You are compressing the spring. If you are compressing the spring, that means work is done on the spring. Work is done on the system, on the spring. And when work is done on the system, W value is taken as positive. So W is equal to plus 10 kilojoule. Right? Now at the same time, 2 kilojoules escaped to the surroundings as heat. 2 kilojoules escaped to the surroundings as heat. That means heat is absorbed by the system or released. It is released by the system. And whenever system releases heat, Q value is taken as negative. So Q is equal to minus 2 kilojoules. So you just have to be careful with the sign conventions. That's it. Now, my dear students, you know delta U is equal to Q plus W. Now Q is 10, W is minus 2. The value comes out to be 8 kilojoules. So this is the final answer. Pretty much simple, yeah? Perfectly done. Amazing. One more question I'm giving you. And I know you are going to do a mistake here in this question. A lot of students will make mistake in this question. Give it a try. Give it a try. Quick. Quick, people. Quick, people. Everyone in the chats. The question is, a system expands from 5 liters to 10 liters. What does it mean? It means initial volume of the gas is 5 liters. Final volume of the gas is 10 liters. A system expands from 5 liters to 10 liters against a constant external pressure. External pressure is given to me as 2 atm. Right? If it absorbs 800 joules of heat, system is absorbing heat. And whenever system absorbs heat, Q value is taken as positive. So it's 800 joules. What do we have to calculate? We have to calculate delta U. We have to calculate delta U. Now, my dear students, you know, delta U is equal to Q plus W, right? So W is given to me in the, Q is given to me in the question. So what do I need? I need W. How do I get the W value? Simple. Minus P external delta V, right? P external is 2 atm. Delta V means change in volume, which is final volume minus initial volume. So 10 minus 5 is 5. The value comes out to be minus 10. But be careful with one thing. Pressure I have taken in atmosphere. Volume I have taken in liters. So units of this will be atm liter. Pressure in atm, volume in liter. Atm liter. Atm liter. And you know, 1 atm liter is equal to 101.3 joules. So W is equal to minus 1013 joules. W is equal to minus 1013 joules. Now people understand. Delta U is equal. Q is equal to how much? Q is equal to how much? 800 joules. Write the units as well, so that you are not going to commit any mistake here. W is equal to minus 1013. So plus minus minus 1013. Write the units as well. Now you are correct. This is in joules, this is in joules. The value comes out to be minus 213. The final answer will be in joules only. Perfect. Be careful with these sort of questions as well. Be careful with these sort of questions as well. Okay. Am I clear with this? Everyone in the chats. Everyone in the chats. I'll move on to the next concept. Amazing concept. Quickly, people. Quickly, people. Everyone in the chats. Yeah? Great. All right. Moving on to one more concept. This is again one amazing concept. Work done in an open vessel. Work done in an open vessel. My dear students, what they'll ask you, they'll give you a reaction. They'll give you a reaction and they'll say the reaction is taking place in an open vessel. The reaction is taking place in an open vessel. They'll say something like that. The reaction is taking place in an open vessel. Calculate the work done. Okay? They'll give you a reaction. They'll say the reaction is taking place in an open vessel. Calculate the work done. Just one result you are supposed to remember. W is equal to minus delta NGRT. W is equal to minus delta NGRT. And whenever this term is mentioned in the question, open vessel, whenever the term open vessel is mentioned in the question, remember, my dear students, take the process as isobaric. Take the process as isobaric. Take the process isobaric. Okay? Now, for example, let's try to solve a question so that you can understand. You can understand few things. See, guys. For example, this is the question. This is the question. Calculate the work done during the complete decomposition of 5 moles of PCl5 in calories at 300 Kelvin. Let me modify the question. In open vessel. In open vessel. This is the question, guys. This is the question. Understand how am I going to deal with such kind of the question. Understand properly. So, first of all, they mentioned open vessel. Whenever I hear the term open vessel, the first result that comes into my mind, that is W is equal to minus delta NGRT. W is equal to minus delta NGRT. Now, my dear students, can I calculate delta NG for the reaction? Yes, I can do that. Few minutes back, I told you. How do we get the delta NG? Delta NG is equal to number of moles of gaseous products, which is 1 plus 1, 2, minus number of moles of gaseous reactant, which is 1. The value comes out to be 1. So delta NG is nothing but 1. Delta NG is nothing but 1. And people, if delta NG is 1, we are done. W is equal to minus delta NG is 1. We need to get the value in calories. If I need the answer in calories, so take the value of R as 2. Temperature, 300 Kelvin. The value comes out to be minus 600 calories. But if I ask you, is this the correct answer of the question? This is not the correct answer of the question, people. No, this is not. Why? Because this is the value of W when we are doing the decomposition of 1 mole of PCl5. This is the value of W when we are doing the decomposition of 1 mole of PCl5. But as per the question, do we have to do the decomposition of 1 mole of PCl5? No, we have to do the decomposition of 5 moles of PCl5. So, my dear students, tell me, when 1 mole PCl5 undergoes decomposition, what is the value of W? Minus 600 calories. Therefore, when 5 moles of PCl5 will undergo decomposition, it's going to be minus 600 multiplied by 5. The value comes out to be minus 3000 calories. This is the final answer of the question. Do you understand? And these small mistakes I have seen a lot of students making during the examination. So I would want everyone to be careful with all of this. Okay. One more question, similar type, so that you become clear with all this. Similar type of question, guys. Similar type of question. Similar. It's not a similar type of question, it's the same question, basically. I would want you guys to give it a try. Now, first of all, let me modify the question. Determine work done in calories in open vessel. In open vessel. Okay, by the way, if they mention closed vessel, then directly take the W value as 0. If they mention closed vessel, take the W value directly as 0, people. Okay? Okay? Now, see how am I going to deal with such kind of a question? Understand. First thing, I saw open vessel. That means the first formula that's coming into my mind, that is W is equal to minus delta NGRT. Now, the first thing which I need to calculate, that's delta NG. How do we get delta NG? Number of moles of gaseous products. Number of moles of gaseous products. This is the gaseous product, this is the gaseous product. How many moles? 4. How many moles? 1. So 4 plus 1 is 5. Minus number of moles of gaseous reactant. There is no gaseous reactant. So 5 minus 0 is 5. So you got delta NG. You got delta NG. After getting delta NG, put the value here. W is equal to minus delta NG is 5. Take the R value in calories. Temperature in Kelvin. What? 27 degrees centigrade means 300 Kelvin. So the value comes out to be minus 3000 calories. W comes out to be minus 3000 calories. This is the value of W. This is the value of W. But if I ask you, is there the correct answer of the question? I'm asking you. Say yes or no in the chats. Is it the correct answer of the question? No, my dear students, this is not the correct answer of the question. This is not the correct answer of the question. This is the value of W when we are doing the decomposition of 3 moles of N2H4. Do you understand? This is the value of W when we are doing the decomposition of 3 moles of N2H4. So when we are doing the decomposition of 3 moles of N2H4, W value is coming out to be minus 3000 calories, right? Therefore, my brain says, when we do the decomposition of 1 mole of N2H4, what would be the value of W? It will be minus 3000 divided by 3 calories, right? But as per the question, are we doing the decomposition of 1 mole of N2H4? No, we are doing the decomposition of 5 moles of N2H4. So multiply 5 on both the sides. So on doing the decomposition of 5 moles of N2H4, it will be minus 3000 divided by 3 multiplied by 5. The value comes out to be minus 5000 calories. So this is the final answer of the question, people. I believe I'm clear with this particular concept as well. If yes, let me know once in the chats quickly, people. Everyone in the chats. Everyone in the chats. Quickly. Everyone in the chats. Yeah? Everyone in the chats, people. Perfectly done. Perfectly done. Amazing. Amazing. Now, there is one more concept, guys, which I would want to discuss with you. What is that? Have you heard about free expansion? Again, a direct question, not the numerical, direct question, right? Theoretical one, which involves a bit of mathematics that can be asked. Okay, so what is free expansion? Let me write its definition first. Free expansion is simply defined as expansion against zero external pressure. Expansion against zero external pressure. Or you can say expansion in vacuum. Expansion in vacuum. Remember, W value is equal to 0. The process is irreversible. So what does all this mean? What is the meaning of all these points? Try to understand what exactly I say. My dear students, imagine that this is your container. This is your container. And here you have got a piston. The piston can come out, it can come in as well. The piston can go out, the piston can come in as well, right? Let's say this is your ideal gas in the container. This is your ideal gas in the container, okay? Now, if there is the ideal gas in the container, how many pressures will be experienced by this piston? I would say this piston right now will be experiencing 2 pressures. One is called as P gas, one is called as P external. This piston will be experiencing 2 pressures. P gas, P external. P gas, P external. Now, if for example, P gas is equal to P external. If for example, P gas is equal to P external. My dear students, if P gas is equal to P external, the piston won't move. If P gas is equal to P external, the piston won't be moving, right? Piston won't be moving. But, if suddenly P external becomes 0, if suddenly P external becomes 0, I would say the piston will abruptly go outwards. The piston will abruptly go outwards. And when the piston abruptly goes outwards, I would say volume of the container will increase. Volume of the container will increase. And if the volume of container increases, I would say volume of the gas increases. Right? So can I say increase in the volume of the gas is what we call as expansion? I would say expansion of the gas is happening against 0 external pressure. Expansion of the gas is happening against 0 external pressure. And my dear students, whenever expansion of the gas happens against 0 external pressure, we call this expansion as free expansion. And whenever you hear the word vacuum, if you hear the word external pressure 0, if you hear the word free expansion, the first thing that should strike your mind, that is W value is equal to 0. Okay? W value is equal to 0. Perfect. Now, my dear students, there can be 2 more things which can be asked. There is something called as isothermal free expansion. There is something called as isothermal free expansion of an ideal gas. Now, what all things I can depict from this particular thing? isothermal free expansion of an ideal gas. First of all, the term mentioned is free expansion. If the term mentioned is free expansion, that means W value is equal to 0. Isothermal, you must be knowing, when the ideal gas undergoes isothermal process, delta U is also 0. When the ideal gas undergoes isothermal process, delta U is also 0. Now you tell me one thing. If W is 0, delta U is 0. As per first law of thermodynamics, delta U is equal to Q plus W, right? If delta U is 0, W is equal to 0, which means that Q is also equal to 0. Perfect. Q is also equal to 0. So in case of isothermal free expansion of an ideal gas, all these terms are 0. They can be directly asked. Which all terms are 0 when the ideal gas undergoes isothermal free expansion, right? Similarly, there can be one more thing asked. What is that? That is adiabatic free expansion. Adiabatic free expansion. Adiabatic free expansion of what? Of an ideal gas. Adiabatic free expansion of an ideal gas. Now, my dear students, I would want you guys to remember the same things again. What are those same things? First of all, the term is adiabatic. The term is adiabatic. That means Q value is 0. The term is free expansion. That means W value is 0. First law says delta U is equal to Q plus W. Delta U is equal to Q plus W. So delta U is 0. If delta U is 0, and we are talking about ideal gas, delta U is nothing but NCV delta T. So this term will be 0. This term will be 0 only if delta T is 0. Now, if they ask you what all terms are 0 when the ideal gas undergoes adiabatic free expansion, so all these terms are 0 here. All these terms would be 0 when the ideal gas undergoes adiabatic free expansion. Let me know once in the chats if I'm clear with this, people. Quickly, 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 everyone in the chats. Everyone means everyone. Everyone means everyone. There can be 2 statement-based questions on this particular thing. Okay? And these are the standard questions which I'm giving you guys, and they will be directly asked. Okay? Or maybe values, etc. will be changed. Perfect. Done with this? Done with this, people? Yes or no in the chats? Now, there is one more frequently asked concept that I would want to discuss with you. What is that? This particular concept. Enthalpy of reaction from bond energy. Enthalpy of reaction from bond energy. This again, frequently asked concept, guys. Now remember few things. Remember few things. Remember few things. Remember, enthalpy of reaction is always equal. Enthalpy of reaction is always equal. Enthalpy of reaction is always equal. Bond energy of reactants minus bond energy of products. That's all. Enthalpy of reaction is always equal to bond energy of reactants minus bond energy of products. Bond energy of reactants minus bond energy of products. Now, how do I use this? Try to understand. For example, I'm giving you the question like this. This is your question. Understand properly. I need to calculate enthalpy of this reaction. Wait. Yeah, I need to calculate enthalpy of this reaction. Bond energy of H2Cl to HCl are given to me. Now, how do I do it? 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 Pretty much simple, guys. You know, enthalpy of reaction is equal to bond energy of reactants minus bond energy of products. Now, first of all, people, tell me, your H2 looks like this. You know it already. This H single bond H. Cl2 looks like this. Cl single bond Cl. HCl looks like this. H single bond C. H single bond Cl. So I can simply say enthalpy of reaction is equal to bond energy of reactants. Bond energy of reactants. I'll start with the reactants. Stoichiometric coefficient here is 1 by 2. So I'll write 1 by 2. Then I'll write bond energy of H single bond H. Right? Plus this 1 by 2. I'll write bond energy of Cl single bond Cl. This is the bond energy of reactants minus bond energy of products. Go to the product side. Stoichiometric coefficient is 1. Right? So write 1. And then you write bond energy of H single bond Cl. Right? Now, people, all these values are given in the question. All these values are given in the question. Put the values and get the answer. Pretty much simple. Is it difficult? No, it's not. And this is frequently asked in the examination. Tell me once in the chats if this is clear to every one of you. Everyone means everyone. Quickly, people. Quickly, everyone in the chats. Again, this is the question, people. This is the question. This is the question. Would you give it a try? Similar type of question this is. Similar type of question this is, people. First of all, the reaction is C2H4 plus H2. It gives C2H6. So first of all, to solve this question, you need the structures of all these. You need the structures of all these. First of all, C2H4 looks like this. C2H4 looks like this. You know it already. H2 looks like this. C2H6 looks like this. Okay? Perfect. Now, what do you have to calculate? Enthalpy of the reaction. Enthalpy of the reaction is equal to bond energy of reactants minus bond energy of products. Bond energy of reactants minus bond energy of products. Start with this reactant. Its stoichiometric coefficient is 1. So I wrote 1 first. Now, in this C2H4, how many different types of bonds do you see? In this C2H4, I can see CH bond and C double bond C. How many CH bonds are there? 4. So I'll write 4 times energy required to break CH bonds. Plus, how many C single bonds? C double bond C? 1. So I'll write 1 and then I'll write bond energy required to break C double bond C. Perfect. Perfect. Now go to H2. Its stoichiometric coefficient is 1. So I'll write 1 energy required to break HH bond. So this is your bond energy of reactants. This is your bond energy of reactants. Minus bond energy of products. Minus bond energy of products. Tell me one thing, guys. Tell me one thing. Stoichiometric coefficient here is 1. Leave it aside. How many CH bonds do you see? 6 CH bonds. And how many C single bond Cs do you see? 1 C single bond C. Now, I believe in the question, all these values are given. In the question, all these values are given. And if all these values are given, put the values, get the answer. That's it. Put the values, get the answer. That's it. Yes. Done and dusted. Everyone in the chats, done and dusted, people. Everyone in the chats, quickly. Perfect. There is one more concept which is frequently asked, people. What is that? That is criteria for spontaneity. Criteria for spontaneity. Remember this particular topic as well. Well, first of all, every one of you would be familiar with the fact delta G is equal to delta H minus T delta S. This is the result between delta G and delta H. This is the result between delta G and delta H. My dear students, for the process to be spontaneous, remember delta G should be negative. If delta G of the system is negative, is less than 0, we say the process spontaneous. We say the process spontaneous. Okay? And if delta G for the system is greater than 0, we say the process non-spontaneous. Right? And if delta G for the system is equal to 0, right? This is the condition for equilibrium. This is the condition for equilibrium. Remember these 3 things. And if you remember these 3 things, you can easily solve the questions. For example, there is one simple question which was asked, which is frequently asked basically. What is the question? You are given with the reaction A gives B. You are given with the reaction A gives B. Its delta H is given to me as 80,000 joules. Okay, its delta H is given to me as 80,000 joules, or keep it as minus 80,000 joules. And its delta S is given to me as 2 times capital T joules per Kelvin. Delta S is given. Delta H is also given. Now, in the question, they are asking me, calculate the temperature. Calculate the temperature above or below which the reaction is spontaneous. The reaction is spontaneous. Calculate the temperature above or below which the reaction is spontaneous. How do I do it? I told you a few minutes back, for any process to be spontaneous, delta G has to be negative. For any process to be spontaneous, delta G has to be negative. Delta G is nothing but delta H minus T delta S. So this term has to be negative. So I would say delta H should be less than T delta S. Or I would say T delta S should be greater than delta H. Or I would say temperature should be greater than delta H divided by delta S. Let's do one thing, keep it positive. Keep it positive on. Now, in the question, what is delta H? Delta is 80,000. Or wait, I can write it like this. Your delta H is equal to how much? 80,000 minus T I'm running as such. Delta S is given to me as 2T, so it becomes 2T square. This is less than 0. So I would say 80,000 should be less than 2T square, or you can say 2T square is greater than 80,000. Or my dear students, remember T square is greater than 40,000, or you can say temperature should be greater than 200 Kelvin when you take the root on both the sides. So I would say temperature has to be greater than 200 Kelvin, then only the reaction, the process will be spontaneous. Okay? Perfect, guys. Perfect, perfect, perfect. Yeah? And there is one question I'm giving you as the homework. Do give it a try and do let me know its answer in the comment section of this particular video, right? I believe this session was pretty much beneficial to you, and I'm pretty much sure a lot of concepts will be directly, indirectly asked from this particular session. Okay? Tomorrow, I'm going to have one amazing session with all of you. I'll be discussing some 30 PYQs. My dear students, this session is going to be very, very, very beneficial. So do join me tomorrow exactly at 9 p.m. That's going to be 1 hour session. Okay? Perfect. So with this, I'll be taking a leave. You take care. God bless you all. Love you all. And my dear students, do let me know in the comment section of the video how much you liked this particular. Okay? So all these 5 days are left for the exam. All these 5 days, I'll be with you every single day exactly at 9. Okay? And tomorrow morning at 9 a.m., I'll be posting a recorded video, 100 marks in 20 minutes. Do watch that as well.